Hello everyone, welcome to my presentation on AWS Glue and Feature Engineering Fundamentals. So my name is Akash Patel and this presentation I will discuss how organization prepare information before using it for analytics and machine learning projects. So in today's world, business collects huge amount of information from website, mobile application, datasets, databases, cloud storage systems, and many other resources. However, raw information is not always ready to use immediately. Organizations often need to clean, organize, transform, and prepare information before it becomes useful for decision making and machine learning. In this presentation, we will learn about ETL processes, AWS Glue, feature engineering, and how these concepts help organizations build better analytics and machine learning solutions. So let's get started. So before we begin, let's quick review the information learning objective for this presentation. By the end of this presentation, we will understand why organizations spend significant time preparing information before analytics and machine learning projects begin. We will learn about the ETL process and understand how information is extracted, transformed, and loaded into the system that supports business operations. We will also explore AWS Glue and learn how it helps automate data integration and preparation activities. In addition, we will discuss feature engineering and see how it improves machine learning performance through practical examples. Finally, we will understand how high quality prepared information help organization build more accurate and reliable machine learning solutions. These objectives will guide us throughout the presentation. So before discussing AWS Glue and feature engineering, we first need to understand why data preparation is important. Organizations collect information from many different sources every day. These sources may include website, mobile application databases, cloud storage system, business software, and customer interactions. The challenge is that information often arrives in different format and structures. Some records may be incomplete, while other may contain error or inconsistency. Raw information is rarely ready to immediate analysis because it may contain missing value, duplicate record, and format problem or incorrect entries. So business decisions depend on reliable information. If poor quality information is used, report and analytics result may become misleading. Machine learning models also depend heavily on data quality. When poor quality information is used for training, model predictions often become less accurate and less useful. Because of this reason, organizations spend a significant amount of time preparing information before using it for analytic, forecasting, reporting, and machine learning projects. Data preparation is often considered one of the most important steps in the entire data management process. Let's move to this next slide. So let's look at some common problem organization encounter when working with the raw information. One common issue is inconsistent formatting. For example, one system may store data as a month, day, and year, while others store them in a completely different format. Another challenge is missing information. Customer record may contain missing phone numbers, complete address, or empty field that make analysis more difficult. Duplicate record are also very common. Sometimes customer accidentally create multiple account, causing the same person to appear multiple time in a data set. Organization may also find incorrect information caused by typing mistakes, invalid value, or formatting error during data entry. Large organizations often collect information from multiple department and system. Combining all of these information into one consider consistent data set can be challenging. Before meaningful analysis can begin, organization must identify and correct these issues to ensure information is accurate and trustworthy. Let's move to the next slides. Let's now discuss about ETL, which is one of the most important concept in data management. ETL stands for extract, transform, and load. The first stage, extract, involved collecting information from different sources such as database, spreadsheets, websites, cloud storage systems, and business applications. The second stage, transform, focus on cleaning, organizing standardizing and improving the information so that it becomes easier to understand and analyze. The third stage load involve moving the prepared information into a destination system where it can be used for reporting, analytics, dashboards, and machine learning projects. ETL help organization combine information from multiple system into a single consistent format, while without ETL process business would often struggle to manage and analyze information that is spread across many different locations. ETL provide the foundation for many modern analytic and machine learning workflow. So let's see, now that we understand the ETL process, let's look at the real world example to see how it work in practice. Imagine a large retail company that sells products through its website, mobile application, and physical stores. Every day, thousands of customer transactions, product update, and sell records are generated from these different systems. The challenge is that the information is stored in different locations. Website data may be stored in a one data set, mobile application data is another system, and store cell records is a separate file. Because the information is scattered across multiple systems, it becomes difficult to analyze everything together. This is where ETL become very useful. During the extract stage, the company collect information from all these different resources and bring it into one centralized location. During the transform stage, the company clean and improve the information, duplicate customer records are removed, formatting difference are corrected, product names are standardized and missing value are handled whenever possible. During the load stage, the cleaned information is moved into a reporting or analytic system where business teams can access and analyze it. After ETL process is complete, manager can generate accurate reports, monitor scale performance, and better understand customer behavior. These examples show how ETL help organization transform scattered raw information into valuable business insights. Let's discuss about AWS Glue. So AWS Glue is a fully managed cloud service provided by Amazon Web Service that help organization discover, prepare, transform, and integrate information from different sources. Many organizations collect information from datasets, databases, applications, spreadsheets, and cloud storage systems and third-party platforms. The problem is that all information is often stored in different format and locations. AWS Glue helps solve this problem by bringing information together into a more organized and usable format. One of the biggest advantage of AWS Glue is automation. Instead of manually move and preparing information, organization can create automated workflow that handle much of the work automatically. AWS Glue support ETL process by helping business extract information from various sources, transform into transform it into a consistent format, and load it into system used for analytic and machine learning. AWS Because AWS manages the infrastructure behind the service, organization do not need to spend time installing software, managing servers, or maintaining complex systems. This allows business to focus more on using information to solve problems and make decisions rather than spending time managing technical infrastructure. Let's move to the next slides. So let's now look at how AWS Glue help organization into the daily operation. Many organizations store information across multiple departments and systems. For example, a sales department may use one database, customer support may use another system, and finance may use completely different software. Because these systems often do not communicate effectively with one another, it can be difficult to obtain complete picture of business operations. AWS Glue help connect this system by collecting information from multiple sources and preparing it in a consistent format. Another major benefit is automation. Business can automate repetitive Tasks such as data cleaning, transformation, and moving information between systems. These not only save time but also reduce the risk of human error that can occur during manual processing. AWS Glue also help analysts, business teams, and data scientists access information more quickly because the preparation process become much more efficient. As organization continues to generate a larger amount of information, AWS Glue help them scale their data processing activity without significantly increased complexity. This make AWS Glue an important tool for reporting, analytics, system intelligence, and machine learning projects. Let's move to the next slides. Let's look at the real world example of AWS Glue in action. Imagine a healthcare organization that collects patient information from appointment scheduling systems, medical record database, laboratory system, and billing applications. Each of these systems store information differently, make it difficult for healthcare administrator to obtain a complete view of patient activity and organizational performance. Without proper integration. Employee may spend significant time manually gathering and organizing information from different systems. AWS Glue helps solve the problem by automatically collecting information from all these sources and combine it into a single consistent dataset. During the transformation process, AWS Glue can standardize patient record, correct formatting differences, and remove duplicate information that may exist across system. Once the information is prepared, it can be loaded into analytic platform where manager can review reports, monitor performance, and identify important trends. By automating such of preparation process, AWS Glue reduce administrative workload and improve operational efficiency. This example demonstrates how AWS Glue help organizations make better decisions by improving how information is managed and prepared. Let's move to the next slides. Let's move on another important concept in machine learning called feature engineering. Feature engineering is process of creating, selecting, and improving information that help machine learning models learn pattern more effectively. At first, this may sound complicated, but the idea is actually very simple. Organizations collect large amount of raw information every day. However, not every piece of information is equally useful for making predictions. For example, imagine a company that customer purchase record going back several years. Looking at thousands of individual transactions may not help machine learning module understand customer behavior very clearly. Instead, data professionals often create a new pieces of information called features that summarize important patterns. For example, instead of using every purchase separately, they may create a feature called average purchases per month. This new feature can provide a much clear picture of customer behavior. Feature engineering help machine learning module identify a relationship and pattern that may not be obvious when using raw information alone. In many projects, improving feature can increase prediction accuracy more than changing the machine learning algorithm itself. This is why feature engineering is considered one of the most important steps in machine learning development. So let's look at a real world example of make this concept easier to understand. Imagine an online shopping company that want to predict which customer are most likely to make purchase during the next month. So the company collects a large amount of information such as customer age, purchase history, number of ordered, browsing activity, and product preferences. While all of this information is useful, using the raw information directly may not provide the clearest understanding of customer behavior. This is where feature engineering become valuable. Instead of using every individual purchase date, uh, the company creates a new feature called average purchase per month. This feature gives a better summary of how frequently customers shops. Another useful feature may be total amount spent during the last 6 months. These features help identify customer who spend more money and may be more likely to make future purchases. The company could also create features such as average order value or number of product purchased per month. These new features help machine learning models understand customer habits much more effectively than raw transactions records. As a result, the model can make more accurate predictions about future customer behavior. This example shows how feature engineering transforms raw business information into a meaningful information that machine learning models can use. So now let's discuss why feature engineering is so important for machine learning. Machine learning models learn from available information. Means that the quality of information directly affects the quality of predictions. A machine learning model is only as good as the information is receives. Well-designed feature help model identify important relationship and pattern within the data. For example, a recommendation systems used by an online shopping company may perform much better when accurately features accurately represent customer interest and shopping habits. On the other hand, a poor quality feature can confuse machine learning models and reduce prediction accuracy even when advanced algorithms are used. Feature engineering helps simplify systems by focusing attention on the data that contribute most to solving a business problem. Organization use feature engineering is many applications, including recommendation systems, fraud detection, customer behavior analysis, forecasting, healthcare analytics, and financial modeling. Another important point is that improving feature often improves result without changing the machine learning algorithm itself. In many situations, better features are more reliable, more valuable than more complex models. This is why organizations invest significant time in a feature engineering before deploying machine learning solutions. Strong feature engineering practice help create machine learning systems that are more accurate, reliable, and valuable for business decision making. So now let's discuss some of the major benefit of AWS Glue and feature engineering. One of the biggest advantage of AWS Glue is automation. Many organizations spend a significant amount of time collecting, cleaning, and organizing information from different systems. AWS Glue help automate this activity, reducing module effort and saving valuable time. AWS Glue help reduce human error. Manual data processing often i- introduce mistakes, but automated workflow help improve accuracy and reliability. When machine learning models receive higher quality features, they often produce more accurate predictions and better business insights. Together, AWS Glue and feature engineering help organizations improve reporting and analytics, forecasting, and machine learning outcomes. These capabilities allow business to gain greater value from their information and make more informed decisions based on reliable data. So before a machine learning model can be trained, organization must make sure information is properly prepared. Information must be accurate, complete, consistent, and organized before it can be used effectively in modern training. For example, organization may remove duplicate records, correct formatting problems, handling missing value, and create new features that improve prediction quality. AWS Glue helps automate many of these preparation activity, making the entire process faster and more efficient. When information is properly prepared, machine learning models can focus on learning more meaningful patterns instead of being affected by error and inconsistency. Organizations that invest time in Data preparation often archive more accurate predictions, better model performance, and storage business outcomes. This is why data preparation is considered a crucial step in almost every machine learning workflow. So before the conclude, let's review the key concept of this presentation. First, we learned that ETL process help organization extract, transform, and load information from multiple sources before analysis begin. We also learned that AWS Glue is a very powerful cloud service that automate data integration and preparation activities, making information easier to manage and use. We learned that high quality data preparation support better reporting, analytics, forecasting, and machine learning outcomes. Another important lesson is that organizations spend significant time preparing information because data quality has a direct impact on business decision and model accuracy. Finally, we saw how AWS Glue and feature engineering work together to help organization build stronger data-driven and machine learning solutions. These concepts are important because they form the foundation of successful analytics and machine learning projects. So this brings us the end of the presentation. Thank you for taking the time to watch this presentation on AWS Glue Feature Engineering Fundamentals. Throughout this presentation, we'll explore how organizations prepare information for analytics and machine learning projects using modern cloud technologies. We learn about ETL process and so how they help organizations collect, transform, and organize information from multiple resources. We also discuss AWS Glue and how it automated data integration and preparation activities, helping business save time and improve efficiency. In addition, we explore feature engineering and learn how creating meaningful features can significantly improve machine learning model performance and prediction accuracy. I hope this presentation helped explain this concept in a simple and easy to understand way and provide a better understanding of how organization transform raw information into valuable business intelligence. My name is Akash Patel, and this presentation is a part of my AWS certified machine learning engineering learning journey at Concordia University, Chicago. I would like to express my sincerely appreciation to my professor, Dr. Victor Swami, for this continuous guidance, encouragement, and support throughout this learning experience. His dedication to helping students develop practical cloud computing, data analytics, and technology skills has been extremely valuable and continues to inspire learning growth and professional development. Thank you again for watching and have a wonderful day.